Okay, we'll get started now. I haven't really prepared anything. I just thought you guys could ask any questions you wanted. And if you don't have any questions, then I might just go over basic equations or stuff like that. But we're mostly just going to be going over any questions you guys have or maybe practice problems, stuff like that.
Oh, can we go over the homework that she gave us today?
The cognity?
Yeah.
Yeah.
I only did 2 questions because honestly, I don't understand it.
Yeah, they were really hard.
That, and then she only taught us this for 2 classes and she wasn't here today. So I don't really know what she expects us to do.
Yeah, I don't think the questions on the test are going to be as hard as the ones on cognity because the ones that we did in class were a lot easier than that. But yeah, let me share my screen. I finished it, so I think I have all of the explanations. Do you want to just go through all of them? Okay. So for the first one, it says the coefficient of x to the power of 5 in the expansion of 3x squared minus 4x to the power of n is negative 768. And then it says to find n, so it says to find that exponent right there. And the correct answer is 4. So first you have to kind of expand it out kind of algebraically, because we know that the first term is going to be to the power of n minus r, and the second term is going to be to the power of r. So, and then you can kind of separate it into you can separate the plain, the numbers, the coefficients from the x's, right? So if you simplify it down, you get 3 to the power of n minus r times negative 4 times r. And then the x squared is to the power of n minus r. And then the x is just to the power of r. And then if you kind of add the exponents and multiply it, then it simplifies down to x to the power of 2n minus r. That's right here. And then we're looking for x to the power of 5, right? So that way we know that 2n minus r equals 5 when the coefficients equal negative 768. Is it okay if I scroll down? Okay. Right, so here it actually just said to guess and check, which seems really, I don't know, that doesn't seem very reliable to me, but it said to guess and check because we know that n has to be more than r because n is the maximum possible term value, right? Or exponent value. So it says you can just guess and check, and these are the possible solutions that you would get if you guess and check for 2n minus 5 equals r, which is if you just rearrange this equation that we had, you can get 2n minus 5 equals r. And then you just kind of guess and check until you get this. And then it just said to take these and substitute it back, take these possible solutions that you have and substitute it back into this general term here, because here we have n choose r, and then 3 to the power of n minus 3 and negative 4 to the power of r. So all of this together should equal negative 768. So you just kind of substitute in these possible solutions until you get negative 768 from this. And then if you guess and check, then you would get the second solution, which is r equals 3 and n equals 4, the middle one right here. So then it was asking for n, right? So the answer would be 4. Does that make sense? Okay. Yeah, this one was really hard. I had a hard time with this one. I don't think the ones on the test are going to be as hard as this because the IB problems weren't as hard as this, but it's good to know it just in case. It wasn't that bad once they showed this algebra. After that, it was a little bit easier to understand. Okay, should I move on to the next one? Okay. So question 2 says, find the smallest value of n that produces at least one x term with a positive exponent in the expansion of 5x to the power of negative 20 times 3x to the power of 4 minus 9x cubed to the power of n. So, okay, so I was confused about this one as well. So I was trying to do both of these together, but it says at least one x term. So that means you would just take the one with the bigger exponent, because this is negative 20, right? Like the one at the front is negative 20. So you're trying to kind of like, you're trying to cancel out the negative exponent, right? So you have, because you're trying to have one with a positive exponent, like it says here. And so and because it says at least one x term, you would just take the bigger, like the one with the bigger exponent, because we're trying to find the smallest value of n. And so this one already has a bigger exponent, right? So you're gonna have to multiply it by a smaller number in order to like cancel out the negative 20. Does that make sense? Okay. Right, so you would just take the bigger one and then you kind of like, you distribute the n, so you get 3 to the power of n and x to the power of 4n. And then you multiply it by 5x to the power of negative 20. And then, so you get 5 times 3 to the power of n equals x times 4n minus 20. And we're trying to get 4n minus 20 to be a positive number. So you just kind of like, I mean, that's pretty easy to solve. And then the first time it's positive is when n equals 6. So I guess you could just like plug in numbers, or you could just solve it. N equals 5. So you would get 4n minus 20 equals 0, and then 4n equals 20, and then n would equal 5. So it's going to be positive for the first time when it's 6. Okay, is that good? Does that make sense? Okay, I'm going to go to the next one. Okay, so number 3 asks, what is the coefficient of x to the power of 6 in the expansion of x squared plus 3 over x to the power of 12? This one is a little bit easier, I thought, because it gives you the n term. You don't have to like find it. And so basically what you're going to try to do is that, because we're trying to find x to the power of 6. So these two x's, like here and then this one, they have to cancel out. And that happens when n, like the exponent, is 6. Because you would get x to the power of 12 plus whatever number, like 3 to the power of 6 over x to the power of 6. So 12 minus 6 would be 6. So you would get x to the power of 6. And then once you get that, you just have to, find 12, choose r. So it would be 6, right? So you would find 12, choose 6, and then 3 to the power of 6, because that's the only other number that's there. That's not a variable. And then if you simplify all of this, then you get 673,596. So that's your answer, because that's the coefficient of x to the power of 6. Okay, number 4. Find the sum of all coefficients, including the constant term in the expansion of 2x minus 1/2 to the power of 3. So I was confused about what the constant term is, but the constant term is just like a term that doesn't have any variables. So like if there was like 20, like just 20, so okay. So like 1/2 to the power of 3 would be a constant term, because there's no variables in that. So there's no way it's going to change. It's always going to be constant, because it's not being multiplied by any variables that are going to change. Okay, so the correct answer was 27 over 8. And so we're trying to find the sum of all coefficients, right? So that's going to be all of the numbers that are like in front of the variables, right? And so first you would have to expand it. So we did that in class several times, I think. I think you can just, because you know that it will be the exponent like going down for the first term and then going up for the second term. And then once you expand it, you get this expression right here. So the coefficients are 8, -6, 3/2, and 1/8. So the 1/8 is the constant term, because there's no variable there. And then if you add all those up, you get 27 over 8. Okay, question 5. If you guys are confused about anything, please stop me. I'll explain it better. Okay, question 5. find the coefficient of the x to the power of 4 term in the expansion of square root of x plus 1/3 to the power of 10. So again, first we have to like get this term to equal x to the power of 4. Like x to the power of 4 should be the only variable here. And then you can calculate the rest of the numbers. So the correct answer was 5. And then, so first to get x to the power of 4 from square root of x, it would be x to the power of 8. Because if you square it, you just get x. So you need like, I'm sorry, I totally lost my train of thought. Yeah, okay, so if you square it, then you would get like just x, and then you need 4 more. So it would be square root of x to the power of 8 equals x to the power of 4. And then you would just, because that's the second term, because 8 is 2 less than 10, and the first term it starts with like the higher number and then it goes down. So it would be the second term. So then you would do 10, choose 2. It would be the third term actually, because like the first one is 10, then 9, then 8, right? So you would have 10 choose 2 times square root of x to the power of 8, which is x to the power of 4, and then 1/3 to the power of 2. And then you would just simplify all of that out, and then you get 5 as the coefficient. Does that make sense?
I have a question on this one.
Mm-hmm.
So if you were at square root of x to the power of 8, how does that get to x to the power of 4?
Okay, so if you take square root of x, you would have to square it to get just x, right? So that's already 2. That's already x to the power of 2. I actually thought it should be x to the power of 6. So I'm kind of confused about like why it's 8 and not 6, because to me, I think if you square it, you get just x, and then you need 4 more after that. But it says it's 8. I don't understand that. If anyone else does, please go ahead and explain. But it says it's 8.
Is it because 2 of the numbers cancel out the square root? 2 of the, or how does that work?
Yeah. So the first 2 of like whatever number you put here are going to be canceling out the square root. So the first 2 are just bringing it up to like just plain x and not square root of x.
I think the way that I understood it was that a square root is like to the 1/2 power. So if you just think about it like that, then it makes sense why it's 4.
Actually, yeah, that's good. Yeah, that makes sense. So if you have x to the power of 1/2, and then you would multiply that by 8, and then it would equal 4.
Oh, okay, that makes sense.
Okay. If there's nothing else, I'm going to move on to the next one. Okay. So this one, okay. I feel like, okay, I personally felt like they got easier. Like the 2 at the beginning were really hard, but the later ones, like this one, was a lot easier. So this one says find the term including x squared in the expansion of square root of x minus y cubed to the power of 5. So in this one, you just kind of have to expand it out until you find x squared, and then you just write out the whole term that includes x squared. So, okay, so the first thing you do is you find like how to get square root of x to x squared, and so that's going to be square root of x times to the power of 4, which means it would be the second term, right? Because the first term would be square root of x to the power of 5, and the second term is square root of x to the power of 4. And then you expand it out, and then the y term would be to the power of 1, right? Since the first one is to the power of 4. Then you just expand it out as normal, you simplify it, and then you should get negative 5x squared y cubed. Okay, does that make sense? there's nothing, I'm going to move on to the next one. Okay, question 7 says, given that 3 plus the square root of 2 to the power of 4 equals ab square root of 2, find a and b. Okay, so for this one was pretty simple because all you had to do was expand it out all the way. There are actually no variables here. You just have to use the binomial theorem and just expand it out, like all the way, like as much as you can. And then once you simplify it all the way down, you get 193 plus 132 square root of 2. So then it's at a plus b square root of 2. So then a would be 193 and b would be 132. I'm just going to leave this here for a second so you guys can see that.
So you would just expand fully and then solve fully.
Yeah, you're just expanding it and simplifying it down, just adding like terms and then like taking it to the power, whatever you need to do. Because there are no variables, so you can actually solve this out all the way. The only thing you have to do is you have to leave square root of 2 as it is. So you basically just treat square root of 2 as if it's a variable because it says to have that in the answer. So make sure you don't actually take the square root of 2 and then multiply by 132. You have to leave square root of 2 as it is. Okay, if there's nothing else, I'm going to move on to the next one. So question 8 says, the sum of the coefficients in the expansion of x squared plus 1 over x to the power of n is 32, and it says to find the value of n. Okay, so then once again, you have to think of like the binomial theorem, which is like NCR x squared. So the first term is to the power of n minus 3, and then the second term is n minus r, and then the second term is to the power of r. And then, so what they did here, it says to just plug in 1 for x because the coefficients shouldn't change. Like if you do Pascal's triangle, the coefficients are always the same, right? It doesn't change because it doesn't change even though the Pascal's triangle doesn't have the variables in it. So here it's saying you could plug in any number for x and you would get the same coefficient. So they just plugged in x equals 1, which made it really easy. So you would just get 1 squared plus 1 over 1, which is 1. So you get 2 to the power of n if you simplify this. And then you just have that equal to 32. So 2 to the power of n equals 32. And then n would have to be 5. Okay. Does anyone want to see this, or can I move on? Okay, I'm going to go on to the next one. Okay, question 9 says the expansion of 3x squared plus a over x to the power of 7 contains a term, it contains that term. And then it says to find the value of a. So we know that the x's have to be equal to x to the power of 5. So first you would figure out how to like cancel those out until it equals x to the power of 5. And so once again, you put it into the binomial theorem where it's 3x squared to the power of 7 minus r equals a over x to the power of r. And you simplify that out until you get, so for the power for x, you just get 14 minus 3r. If you algebraically, like if you just solve all of that, you get 14 minus 3r. And we know that it has to be equal to 5. So if you set that equal to 5, you get r equals 3. And then you just put r back into this equation. And then you would, and we already know what the coefficient is, right? So you put the coefficient there and then you put r wherever it can be plugged in. So the only variable left is a, and then you just solve for a. If there are no questions, I'm going to move on to the next one. Okay, so this is the last one. Number 10, it says, use Pascal's triangle to find the possible values of n if NCR equals n choose 3 equals 20. So basically, okay, so what they're saying is that so the term number is 3, right? That means it's the fourth term because it starts at 0. So you would have 0, 1, 2, 3. So it's actually the fourth term. So you're looking for the row in Pascal's triangle where the fourth term equals 20. So you just write down Pascal's triangle. There's really no easier way to do that. You just have to write it down and find the row in which 20 is the fourth term, and that's the sixth row. So then n would be equal to 6. Okay, that's the last one. If you guys want me to go over any of them again, we can do that, or we can go over any other questions you have. We could go over like basic equations if that's what you guys want.
I have some
Can you go
questions
over
on
number
paper
one?
too.
Number 1?
Yeah, you over that one.
This one? Right.
Yeah, that one.
Okay. What are you confused about?
So how exactly do you find n? Because I tried doing it that way, and it pretty much I just had to like substitute numbers and to find it, because you just kept getting variables and exponents.
Okay, so what they did here is that they put it into the binomial theorem, right? So the first term would be to the power of n minus r, and the second term would be to the power of r. And then you separate like the constants from the variables. So you just take out the constants because we don't need those right now. So if we take out 3, we still have 3 to the power of n minus r, and then we have -4 to the power of r, which came from the second term. And now you have the x's and the exponents kind of on their own. And then if you would multiply 2 times n minus r. So you get x to the power of 2n minus 2r, and then you still have x to the power of r. So then you would add those, and then you get x to the power of 2n minus r. And then we know that we're trying to find x to the power of 5, or the coefficient of x to the power of 5. So then we know that 2n minus r has to be equal to 5. And then if you like manipulate that a little bit, you would get 2n minus 5 equals r. And then here they just have to guess and check, because we know that n has to be more than or equal to r, because it's like n is the maximum amount of terms. So you just kind of guess and check, and you would get these like possible solutions. And then once you have these, you can test each like set. So r equals 1, n equals 3. You would take that and you would plug it back into here, into these, and choose r 3 to the power of n minus r and -4 times r. And we're trying to find the one where all of these constants to the power of whatever n and whatever r equal -768.
Okay, that makes more sense. Thanks.
Okay, yeah, so you would find it to be like the second set where r equals 3 and n equals 4, and then the question was asking for what n is, so then it would be 4. Okay, did someone else? I think I heard another question too. What was that? Okay, if no one has any other questions, I think y'all can go if you guys got what you needed to. If you have anything else, you can stay. I think I'll be here until 6:40. But if there are no other questions, we can just end here.
I have a question over the paper 2 practice, if you want to open that up.
Okay, yeah, I can open that. Did we do the paper 2 practice in class?
No, we probably were going to do that today, but she wasn't here.
Okay. I don't think I've done those questions, but I can try to solve it for you.
I have a basic one on the first 1b, the term x to the 7th and the expansion 5x. I just have a question, like how would we like present that like as an answer? Because I found the x to the 7th, but then there's a 5x in front of it. I'm not really sure what to do with that.
Okay, hang on. I think it's loading. Number 1, you said?
Yeah, 1b.
Okay. Okay, so it says to find the term x to the power of 7 in the expansion of 5x times x plus 2 to the power of 9. So whenever it says find the term, you write the whole term that includes x to the power of 7. So it would have some number in front of it. It would have a coefficient, so you would write the coefficient x to the power of 7.
Oh, okay, so we would find the coefficient, and then what about the
Yeah.
5x though? Would we multiply that coefficient by 5x?
Yes, you would have to find the term where this whole thing is equal to something times x to the power of 7, but there should be
Oh,
no other x other than that x to the power of 7.
so we use the equation from the one before, which with the x to the 6th, because once you multiply that by the 5x, it turns into x to the power 7.
Okay, yeah, I mean, I haven't done that, but if you see that there, then yeah.
I think
Um,
that's it. I'm not
but
really
make sure you write like the whole term. Don't just write the coefficient or the variable term. Just write the whole thing.
Okay, thank you.
Yep. Anything else? Okay. Harry, do you have a question?
Yeah, so on number 6 on that same thing, it says the constant term is 16,128. Does that just mean that like when there's no x that the equation is equal to that?
Yeah, I think this would be like that. Um, okay, I haven't solved this one, but I think it would be like the cognity one that we did where they plugged in x equals 1. So I think you could plug in.
Hardy's right. If I remember correctly, she said something, you solve that, but since there's no x's and you don't need the x's for that like certain part for the constant one, you're able to find k. Since
Oh,
the
okay, so
x's
you just
cancel
cancel out the x's and
Yeah.
just solve for k. Okay. All right, thanks.
Well, if that's it. Thank you, Prachi.
Yeah, of course. Bye,
Thank
guys.
you.